Right now, under our feet, there's this vast, hidden world, a super complex network of pipes and tunnels. It's basically the circulatory system for our cities, a total marvel of engineering that's quietly making our modern lives possible. So today, we're going to pull back that manhole cover and take a look inside. It's one of those things we just take for granted, right? You turn on the faucet, water comes out. You pull the drain plug, and poof, it's gone. But it doesn't just disappear. That's actually the start of a really long journey. And how we design that journey, well, it has huge consequences for our health, our environment, and yeah, our wallets too. And believe me, the stakes are incredibly high. As our source material puts it so perfectly, this stuff is the cheapest module to master and the most expensive to get wrong. I mean, think about that. Get the basics right, and your city just works. But get them wrong? The costs, both in money and environmental damage, can be absolutely catastrophic. Okay, so let's get into it.
To really navigate this hidden world, we first need to learn the lingo. And these aren't just a bunch of boring technical terms. They're actually super important distinctions that decide how entire citywide systems get built.
First up, the big one, sewage. This is pretty much the catch-all term. Think of it like a giant umbrella. If it's liquid waste and it's flowing in a sewer pipe, whether it's from your house, an office building, or even rain washing down the street, it's all considered sewage. It's our starting point.
Okay, now let's get more specific. We've got what's called sanitary sewage. This is all the wastewater we create inside our buildings from our toilets, showers, kitchens, washing machines. And here's the key thing to remember. This is the stuff that puts a real load on a treatment plant because it's filled with all the organic gunk and pathogens that have to be carefully treated and removed.
And on the flip side, there's storm sewage. This has nothing to do with what's going on inside our homes. It's just rainwater, pure and simple, running off of surfaces like roads, roofs, and parking lots. Now, it's way cleaner than sanitary sewage, obviously. But the challenge here is the sheer volume. During a big downpour, it can be a massive amount of water to deal with all at once.
And we can break it down even further. Even within that sanitary sewage category, there's a vital difference between black water and gray water. Black water, from toilets and kitchen sinks, that's the nasty stuff. It's got the highest concentration of pathogens, and it absolutely must be treated. But gray water, from your shower, your bath, your washing machine, is much less contaminated. And here's why that matters. Sometimes that gray water can actually be recycled for things like watering your garden or even flushing toilets. That's a huge win for water conservation. So now we've got the vocabulary down. How do engineers actually design a system to handle all these different types of water? Well, it turns out there are basically three main philosophies, three core blueprints for how you drain an entire city.
First up is the separate system. The logic here is super simple. Keep the dirty water and the cleaner water separate. You build one network of pipes just for the sanitary sewage, which goes straight to the treatment plant. And then you build a second, totally separate network just for the stormwater.
The beauty of this system is how precise it is. Since you're only treating the really dirty sanitary stuff, your treatment plant can be a lot smaller and way cheaper to run. Plus, since the rainwater has its own dedicated highway, there's basically zero risk of the system overflowing in a big storm. So what's the catch? Well, it's the most expensive to build. I mean, you're literally digging up streets to lay 2 full sets of pipes. And trying to install this in an old, already packed city? Forget about it.
All right, the second approach is the total opposite. It's called the combined system. Here, it's one pipe to rule them all. Everything, your toilet flush, the rain on the street, all of it gets mixed together and flows through one single giant sewer on its way to the treatment plant.
Now, the big selling point here is the upfront cost. It's obviously way cheaper to lay one network of pipes instead of 2. But, and this is a big but, the downsides are pretty serious. Your treatment plant has to be absolutely massive to handle not just the daily sewage, but also the huge surge of water from a rainstorm. And if that storm is too big, the whole system can get overwhelmed. That leads to something called a combined sewer overflow, or CSO, a huge environmental headache we'll talk more about in a bit.
And finally, there's the compromise solution, the middle-of-the-road option, the partially separate system. This is a hybrid approach. It takes the sanitary sewage and mixes it with some of the cleaner stormwater, usually the water coming off of rooftops, and puts that into a single pipe. The rest of the runoff, like from streets, gets its own drain.
This system really tries to find that sweet spot. It's cheaper to build than a fully separate system, and the treatment plant is a more manageable size than what you'd need for a combined one. It even has a cool side benefit. That rooftop rain helps flush the sewers and keep them clean. But it's no silver bullet. The risk of an overflow during a really intense storm is still there, and the engineering behind it is pretty complex.
Okay, so we've met the three main players. Now let's put them head-to-head in a little showdown to really see how they stack up against each other.
And this table really tells the whole story, doesn't it? It's all about trade-offs. Look here. The combined system has the lowest upfront building cost, but it needs the biggest treatment plant and has the highest risk of overflowing. The separate system is the exact opposite. Costs a ton to build, but you get a small, efficient plant and almost no overflow risk. And the partially separate system? Yep, it's sitting right there in the middle on pretty much every measure. The right choice really depends on a city's money, its age, and even its climate.
Now here's a great little insight from our source material, a classic mistake people make. You look at the options and see that the combined system is the cheapest to build, so you think, well, that's the best one. But you're forgetting about the long-term running costs. That absolutely massive treatment plant you need for a combined system, it just kills it financially over the years. The initial price tag isn't the whole story, not by a long shot.
Okay, so we've talked a lot about pipes, costs, and different types of water. But why does any of this actually matter to us in our daily lives? What's the real-world consequence of picking one system over another?
Well, it really comes down to this one pretty nasty event, a combined sewer overflow, or CSO. This is what happens when a combined system gets hit with a heavy storm and just can't keep up. To stop sewage from backing up into basements and streets, the system has emergency outlets that dump everything, a mix of stormwater and raw, untreated human sewage, directly into our rivers, our lakes, and our oceans. That high risk we saw on the chart? This is it, a real disgusting pollution event.
And that brings us to the final big question. The sewer system under your city was probably designed and built decades ago, maybe even a century ago. It was based on the population, the climate, and the technology of that time. But our world is changing, right? We're seeing more extreme weather, and our cities are getting bigger. So you have to wonder, is that hidden system chosen so long ago still the right one for the challenges we're going to face tomorrow?